Hello all. Welcome to my Dr. GY lectures. So, in continuation with my previous session regarding the IoT, so let me talk in detail regarding about the mechanically fastened joints. Generally, mechanical fasteners can commonly used in many advanced engineering applications. Let me dealing with the composite laminates play the main role of transferring the loads between the linked structural elements. This present study, which has been mainly focused on pinned joints, explores the possibility of applying a direct method for evaluating the joint strength and as well as predicting some of the more common joint failure mechanisms. A limit analysis of numerical approach in order to do the statically loaded pinned joint with the help of orthotropic laminates in the plane stress conditions which has been proposed. Mechanical properties of composite laminates nowadays widely employed in many advanced engineering fields. Let us make them attractive for structural applications where high strength to weight and stiffness to weight ratios which are required. Generally, mechanical fasteners like bolts, rivets, pin connectors, which are commonly used in these applications for transferring the loads between the structural components. Such fasteners extensively used mainly because they are easy to assemble or disassemble, and it has been characterized by an high stress concentration which has been happened near the whole area, in which become a source of weaknesses, the structural joint failure mechanisms, which is usually beginning at the fastener sides. So this is what we need to design for mechanical fastener joints in terms of numerical approaches. So generally, let us consider a pin load rectangular composite plates. Okay, for example, let us take the fixture test which has been considered for the load bearing capacity under evaluation and as well as the geometry. The boundary and loading conditions of the pertinent mechanical model are sketched here. Let us take, there is an upper grip is there and also there is a lower grip is there. Here there is a pin which has been attached along with the mechanical fastening joints, and wherever this specimen which is mentioned or shown in this diagram, which having a length of distance L, and their elastic modulus is E, and in the same time the dimension has been keep on varying with the pin direction. Okay, and by applying the axial load on both sides, let us fix with the moment of the pin which has been analyzed in both the specimen direction and as well as the load applying direction. So in this second diagram we just seen, let us take a truss element. Generally, when using the truss element, we having so many fixed joints, and along with the fixed joints there is a circle which has been installed at the workpiece. Okay, so this circle having some dimension, that is a diameter D, and it having the boring size of Z, and wherever the tension of the fastened joints which has been calculated with respect to the angle made by the hole, the tension of over the surfaces which has been equally distributed from the load of applying direction and with respect to the pertinent mechanical model, and based upon the fixture test we are performing about their load bearing capacity evaluation. Okay, so this in plane or shear strength or mechanically fastened joint, which includes the consideration of the bearing failure in case of the joint and as well as the shear failure of the shank of mechanical fastener. Depending on the joint configuration, the in-plane strength may also include consideration of bending failure of the shank of mechanical fastener, and if it is large out of the plane deflections occurs before the failure, the fastener head can pull through the panels in the joint. The critical failure load of the joint will often include the combination of all the above effects, but also we can call it for the bearing strength. So the total load which has been acted on the net tension and the shear out along with the bearing load in the same way of the tear out and along with the cleavages which has been total consideration has been made in order to calculate about the bending failure. So let me continue in next class with a new topic, and thank you so much. By the way, I'm Dr. Yuvaraj and I'm AP Mechanical from SNSCT. Thank you so much.